Goddess of Science Physics, and I'm Mrs. Bulvin, and today we're going to do some problems, practice problems dealing with impulse. I'm like kind of looking around here, looking for a pen that might show up nicely for you guys. Sorry I'm not a little bit better prepared, but let's get after these problems. Okay, so the first one says a mongoose is sitting in a cart that is rolling toward a banyan tree. When the cart and its mongoose passenger hit the tree, it exerts 37.2 newtons of force in the forward direction. So force is 37.2 newtons forward. On the tree, it takes 1.8 seconds to stop, so that's a time. And we want to know what the impulse is, and weirdly, impulse is a J. So looking for a formula that has J, F, and T up here, well, looky there. There's one right there. So that's the formula we're going to use. So J equals 37.2 times 1.8. So when you multiply that together, you end up with 66.96 Newton seconds. Again, awkward unit. Newtons from force, seconds from time. And because force is a vector, that means that impulse has to be a vector. So we need a direction here, and the only direction that we have is forward. Okay, this is the first one. The next one, a roller skate has an impulse of 4.5, let me straighten the paper a little bit, 4.5 Newton seconds. When it runs into a sleeping Great Dane, so this would be toward Great Dane, that would be our direction, named Marmaduke. If it takes a time of 2.1 seconds to stop, what is the force that is applied? So again, J equals Ft. So we got 4.5 equals the force times 2.1 divided by 2.1. And when we do that, we get 2.14. And we're looking for a force in this case, so that would be newtons, and force is a direction. So we could either say forward or toward Marmaduke. There you go. Okay. So the next one is Bellatrix the cat is sliding across the kitchen floor and hits the refrigerator. If Bellatrix has an impulse equals 13 Newton seconds and hits the fridge, so this must be toward the fridge, with a force of 8.9 newtons forward. So we can use forward for both of these. How long does it take Bellatrix to stop? So we're looking for time. So again, J equals Ft. So we got 13 equals 8.9 times T. We're going to divide both sides by 8.9. And when you do that, you end up with 1.46 seconds. Okay, now we got to slide my paper slightly here so that we can see the last one on this page. I'm going to try a little focusing here, so don't think if it gets blurry it's something's wrong, it's just I'm focusing. There we go, it's a little bit better. A ring-tailed lemur is leaping through the air and strikes an acacia tree with a force of 1.5 newtons right. If it has an impulse of 2.1 Newton seconds to the right, how long does it take the leaping lemur to stop? So J equals Ft. So we have 2.1 equals 1.5 times t. We're going to divide both sides by 1.5. all that business and get the t by itself. And if we do that, it's 1.4 seconds is the answer. Okay, so that takes care of the first four. I got a slide of paper out here. Pull this thing down so that we're kind of in the window of possibilities here. An out-of-control radio flyer wagon is filled with watermelons, runs into a rose bush, and stops in 8 seconds. So time equal, not 8 seconds, 0.8 seconds. If it exerts a rightward force of 25.2 newtons to the right on the rose bush, what is the impulse? So we're looking for J here. So J equals Ft, and J equals 25.2 times 0.8. And when we do that, we get 20.16 Newton seconds. And because everything's going to the right here, that's what we need to use. All right, the last one on this page is probably the most difficult one. But if you use a 5-part problem solving method, it shouldn't be a real huge hill to climb. So we're going to read it. We're going to write down what we find when we get through there. So a box truck is filled with chocolate chip cookies, is moving at 14 meters per second to the north. So that's the velocity. When it hits an oak tree and comes to a stop, it exerts a force of 3,500 newtons on the tree, and it must be moving to the north. And it stops in 2.6 seconds. What's the mass of the box truck? Well, it seems like we either have too much information or not enough information. But in fact, we actually have just the right amount of information. Because if you look here on the top of the paper, we know that impulse is change in momentum. And if we just do a little substitution here for the formulas, we can use this formula here because we're given this, and we should be able to find that. So we'll use that formula, m change in v, and we don't really have to worry about the change in velocity because it's going at 14 meters per second and then it stops. So what's the change in velocity? It's 14 meters per second. So we got mass times 14 equals the force, which is 3,500, times 2.6. So we're going to divide both sides by 14 to get the mass by itself. And we're going to multiply 2.6 times 35,000, not 3,500, 35,000, and then divide it by 14. And we're going to get 65,000 kilograms. So we just kind of smushed the two formulas together because we had P equals mv and we had J equals Ft, and because J equals the change in momentum, we can actually put them together. So J would be Ft equals mass, which is not changing, times the change in velocity, or just the velocity in this case. So we can use this formula to solve this problem because we have 3 of the 4 things. Okay, well, that's it for this time. I hope that was helpful for you. Have a good day.